This is the Amp Hour Podcast, released August 12th, 2018. Episode 403. An interview with Mike Szczys. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Mike Szczys, Editor-in-Chief of Hackaday.
And that is how you say it, folks. Mike Szczys. I've been correcting people for you, just so you know, like all these years.
See, now I avoid it myself. I generally introduce myself as Hackaday Mike,
yeah,
at least when I'm at Hackaday Things.
Right.
When I'm not at Hackaday Things, then I don't.
Right. Yeah, that'd be weird. Talking to your wife's friends, and you're like, "Hi, I'm Hackaday Mike. What's wrong with him?"
Yeah, I answer my personal cell phone. Hello, Hackaday Mike here.
Yeah, right. You're on with Hackaday Mike. What's hanging? What's hacking? So we are at DEF CON.
DEF CON 26, yeah.
Mm-hmm. Another one. So my first DEF CON was 22 with you.
As was mine. We had a raging good time that weekend.
I actually did not enjoy that first one.
Really?
I mean, we had some fun parties and stuff, but so this is an interesting thing we can maybe talk about is like, DEF CON felt really cliquey to me, and like, it's not that I feel, I don't feel upset by it. It's just like, I feel kind of icky. It's like, I want to be part of. You know, it's like a FOMO thingy. I want to be part of it, and when you don't hear about things, you're just kind of like chasing. You know, when things aren't well publicized, you're just chasing party. There's a lot of events and talks and whatever, and literally you are going to miss things because it's such a big conference.
I'm kind of surprised because, like, I feel very comfortable just going up to strangers and injecting myself into the conversation and seeing how it goes. And it feels like you have that same skill.
Some days. I mean, not always though. And I've gotten better at it. Maybe hanging out with you. So we should mention. So background. I used to work for Supply Frame.
Yes, and Supply Frame owns Hackaday. They're wonderful overlords who make everything possible, from live events to going to other live events and producing, great pieces of long-form content. Yeah, and you guys have been furiously writing as you. That's always the downside for you, I think. It's like you're writing as you're, while you're experiencing it. It's like, I have to pop away and get this thing published. Yeah, in general, I try to spend part of each day finding a good story, and then part of each day writing it and trying to get it out. And so, for the most part, I have a great time at events, but I have this anxiety that I'm not going to be able to find the cool thing. Right. Like you're going to go to a talk that you thought was great, and it's not, and then you've been stuck there for an hour, and maybe you get up and leave and feel rude about it. Nah, I don't worry about that. But I think it more so that you're missing other things. Yeah. And actually, speaking of missing things, like it's Saturday afternoon, and I still have yet to go to a talk this weekend. Yep. That sounds familiar. I really wanted to go to Mike Osman's talk, of huge regular on the show. Oh yeah. And he, does wireless hacking village stuff, and I went to his talk last year, and I think that was probably my favorite thing of the entire year. Yeah, that was fun. That was the. I actually have talked about that because that was the encoding, right? Digital signal spread spectrum. Right. I remember the code. It was like it was forward error correction, right? Because it was like you have this huge number, and that you can basically dig signals out of noise. I remember that piece. Yeah, he took this huge noise signal, and he was using New Radio. GNU Radio. Right. Derek Kozel's been on the show from GNU Radio. And I had maybe written some stuff. I definitely read a bunch of stuff about it, and you kind of look at it and you're like, okay, it's graphic, and then you maybe don't understand any more of that. But Mike Osman has an amazing skill of taking a difficult problem and breaking it down into a very approachable set of things. He also has crowd management skills, so people were interjecting their helpful little things during it, and he was just not letting himself get off track. But I went out of there feeling like, if I wanted to sit down and study and spend some time on this is a tool that's not out of my reach. And that's really cool. That's the way I want to feel coming out of a talk. Yep, definitely. While we're mentioning GNU Radio, I should mention Derek told me from GNU Radio they're having a convention out here. I think in September, October. Really? And they're doing this. Actually, they have a sponsor, and they're giving away STRs to all the students that are attending. It was really sweet. So, not pitching. That's not sponsored here or anything like that. But it seemed like an interesting thing for people that haven't heard about it. So. I think it's important because I think that's where everything's going. As we design more things, it's going to be less and less specialized radios if we can. Yeah, totally. So, well, speaking of specialization, how did you get here? That was a terrible segue. How did we get Hackaday, Mike? What is the? Oh, how did I get onto the Hackaday thing? Yeah, sure. So, I guess maybe I should explain my background,
Right.
which is that my career is actually as an orchestra musician.
Yep.
So
Always fun to hear people. I always watch as you say that, and people are like, "Wait, what?"
yeah, I still play in 2 orchestras in Madison, Wisconsin. I have 2 college degrees in music performance, and it's like what I always wanted to do, and I'm glad that I'm able to do it.
You got to say which instrument. Come on.
Oh, I play French horn.
Yeah.
And you know, I'm really in a lucky position with the orchestras that I play in because we do kind of everything. I play through those orchestras. I play in an opera orchestra, play in a chamber orchestra, a full symphony orchestra. I've played like Beatles tribute concerts and Led Zeppelin tribute concerts, and yeah, so I get a chance to do everything that I wanted, except for make a lot of money at it. So
Oh yeah, musicians.
yeah,
I remember that. Yeah.
those jobs are like maybe 2/3 of an income, no benefits, and so my wife and I, she's also in the 2 orchestras, have always scrambled for the other part of that living. And going back to like 7th grade, I've been, you know, like computer geek, hacker guy.
It's just a weird. The music plus tech isn't weird, but it's the fact that you actually made it work. And as the musician, I don't know. I know a lot of people who are in tech who play music, myself included. I don't know many people who are in music and do tech.
Yeah, I guess there's probably a lot of people who tried to do music and ended up not finding the job.
Sure,
you know,
right, yeah, exactly, yeah.
Yeah, I feel really lucky for that. It's, you know, in the orchestra world, it's like somebody has to leave
Yep.
a position, and then there's an audition, and so, yeah, so I feel really fortunate. But I started, you know, writing part-time for Hackaday as a way to kind of round out my income. I was also like teaching private lessons, French horn lessons,
course,
like going to schools, and then also like when my wife and I bought a house, we built a soundproof room in our basement because you don't want to teach 7th grade French horn players and bassoon players if the other person is in the house, or they will go batty.
Yep.
But you know, I kind of moved up and up and up with Hackaday, and then when SupplyFrame bought the site in 2013, I had the option to go full-time, and really never looked back. It's been an amazing experience.
Yeah, and that's just about when I started in 2014, so yeah, just about the same time. So it's been good getting to know you. It's been real, you know. We'll see you later.
Yeah, well,
Nice.
you know,
This is the end of the friendship. No.
you're dead to me now.
Yeah, right.
That, no, but I do cherish the time that we worked together. I felt that both professionally and socially, you were always someone that I could work really easily with.
You know, the Midwesterners, we get along, you know.
Yeah.
So you live in Madison, Wisconsin.
I do, yeah, and it's much better than any other place.
Oh.
No,
Especially if you like cheese and beer.
you know, it's a great city. It's a Big Ten college town, and it's also the state capital.
Yep.
But it's only like, you know, like in city limits is like 250,000 people. I think maybe the county is like 500,000.
Yeah.
So there's some stuff going on there. You can always kind of find something to do, but you can also get anywhere in 20 minutes or 30 minutes, which is cool.
Yeah. Well, so to go back to the SupplyFrame stuff, we kind of launched in. Well, I helped you and the rest of the team when the Hackaday Prize started, and that's still going, right?
Yeah, it is. It's in its 5th year now, and it's our global engineering initiative that really looks at, you know, all this creativity and skill and expertise that the Hackaday community has, and says, hey, can you spend part of your time actually thinking about something that can make the world a better place for people? And
sorry, man.
Yeah.
Every time I hear that, I just think of that clip in Silicon Valley first season where it's all people at TechCrunch, and like they always end their presentation, and that's why we're making the world a better place.
Yeah, and I get the bullshit meter tweaks a little bit when you say things like that, but I do think that there's a chance to move the ball on this, and the thing is, if everyone was like, oh, I have to set out to do this thing in order to make the world a better place, no one would ever try. And if you look at the majority of the projects that are entered are not going to change the world. That's not really the point of them. I mean, I think the point of it is to look at it and say, we have amazing power as individuals to learn things and then to apply that knowledge and to pass that knowledge on forward. And so I often think the kit that you're working on for your Hackaday Prize entry this year could end up being the thing that inspires someone that actually does go out and makes a discovery, or does go out and start a company or join an initiative. And I think I always think about, like, how do people get ideas? Where do ideas come from? And I really think it's pollination from person to person to person.
Yeah.
And what
It's
this
like
is this is trying to collect pollination of topics into one spot, and then kind of you
like highlight it, and you celebrate it. Yeah, that's a good point. Yeah, I always think about that too. Like on the teaching side of things, like teaching is a noble. Not that I'm a teacher. I don't consider myself a teacher, but like like if you're doing education stuff, you're passing that stuff on. You're trying to get that next. You're not necessarily going to solve world hunger or save the world from climate change, anything like that, but one of your students might. You know what I mean? And there's an important thing there, and it's like it is just the thing that has to keep happening. So
yeah, and through music, like in college, I would go and have an hour lesson with my professor every single week, one-on-one, in a room with no one else there. And I didn't really realize until after I was out of grad school that like that's not the experience that most people have.
Right.
But like looking back on it, that kind of that pedagogy of learning knowledge and passing it on is totally alive and well in the hacker world and in the engineering world, where like you form a team, and then the skills from each person on that team are generally worked on a one-on-one basis when the need arises. And I think you shouldn't have to be working for a company in order to get that. Like if you're working on a hobby project that someone else has an interest in it, or if you have a problem, you should be able to like collaborate using the tools we have with the internet, and also the kind of the tools that we have to get together in person. Like you may not have someone that's right down the street, but you probably have someone that's pretty close to you, and if we can use these online communities to make those in-person happenings occur, there's
increasingly
great
rare
power.
and more important, I think. Right.
Yeah, yeah, and I also think we just need to make sure that we don't end up with this like concentration of engineering all in one place. Like Silicon Valley is the only place that
at
you can
Apple,
go.
right?
Yeah,
or
exactly.
At Google, right? Yeah.
Yeah, I mean we need it in Poughkeepsie.
Yeah, we do.
Sorry, Poughkeepsie. I have no idea.
Yeah,
I just pulled that out.
Mike hates Poughkeepsie. Mike Stish hates Poughkeepsie. Yeah, I mean, so I've actually talked to Alicia from the Embedded FM podcast, who you've also been on Embedded.
One of my favorites. And
I enjoyed your stories about the Butter Factory. I'll leave those stories over there, so I'll point people over to that.
Yeah, the Butter
Factory.
Factory.
I'm probably not gonna have many notes for this show, but oh well. The Butter Factory sounds weird, but go listen to that show. That's another great interview they did with you. But me and Alicia have talked about when you move outside of school, right? And specifically for her, she's a consultant. When you move outside of engineering, or even if you are an engineer and you're in a company, you're just moving up, you're 10, 15, 20-year engineer. Like, how do you learn that next thing? You don't have a lesson, right? And so it has to be that more collaborative, sit down with other people and just kind of figure stuff out, and you can pick up tips and tricks. Again, the music thing. So when Akiba was on the show, he talked about breakdancing, I talked about jazz, but like that idea of like playing with people and like learning in situ like that is like a really important thing, where you're replicating what others are doing, and then you're borrowing it and you're transforming it and moving out of that. So is that kind of what you mean with the Hackaday Prize, or what?
Yeah, I think that when you put something out there, you're like, let's say air quality monitor. We've had a lot of air quality monitors on there, and there's going to be a lot more air quality monitors because it's not like pollution is currently looking like it's improving. Right?
Fix that one.
Yeah,
right.
Yeah. I think the more people we have, and our continued need for the lowest possible price on energy for that part of the world, it's going to continue to be a problem. And we're only recently starting to do widespread monitoring in certain parts, and those monitors tend to be they're not cheap. They're not super expensive, but you do need a lot of them. You need to put a network together.
Right.
So like having the ability to go out and say, let's look at as many examples of people who have been working on this as possible, and let's see, are there certain sensors that are really popular? Are there certain circuits designed around those that work really well? Why are those choices being made, and do we see a trend here? Do we see the same dead ends being hit, and do we need to find new technology for these? I think one of the ideals of the Hackaday Prize is that it should be an open source project, so people should be able to look at the code that you're using for it. And so what you end up with is there's a high signal to noise ratio, but there is a place that you can go and find collections of example builds, example code.
And so do you find that like people are actually making appreciable like efforts towards open source projects? 'Cause, I mean, I think this is also maybe a hardware versus software type of thing as well, right? There's always that, well, open source hardware is a good thing, but does it actually lead to the next thing, right? And does it lead to the next project? Is there any tracking of that through the Hackaday Prize of like, oh, well, this new project started because of that old project?
Yeah, and actually we see it more often than you would think. The one that just popped to mind is PCB motors are kind of like a big trend this year. And so I can't pull the name out of my head right now of who did the first one that I saw, but it was a little like 6 coils on a PCB and a little
metal ball
stator that. Well, this was the first one that he did. So it was like a little stator that was 3D printed and had a few neodymium magnets in it.
Okay.
And basically, I mean, it's like a brushless motor flipped, right? So the stationary part is the coils, and you can drive it. And then another person who I think his name is Bobricus.
Let's just not. We'll try and get links later. How about that?
Oh yeah, that sounds
instead
good.
Instead of butchering names.
Yeah, he went and he's like, you know, this is a good idea, but I think you can get more power out of it if you use like multiple sandwiches of PCBs, and then ended up like doing a proof of concept where this could be like a propulsion system for a tiny robot, and like shows it like driving across the table, and that was like a direct inspiration from the first project. And then the gentleman who did the first one then came out. Oh, it might have been Bobricus again, who had the strip of coils and a ball magnet that moves back and forth. And then there's another one that's like the coils are in a flexible PCB, and it's really wicked. And what I like about it is, you know, with Hackaday, I often say, if you ask why, it's the wrong question. I mean, really, what this is like research and development, and it's waiting for, you know, the person who has the killer app to come and find it, or someone to stumble upon it.
Yeah. Well, and I think too, I've been really intrigued by super low cost stuff recently, right? So like Espressive is a great example of that. They didn't have a great. They still don't have a great product, right? It's very impressive for what it is, but it's not like super well done. And but like you can't stop that. That's what I really like about it. And I think that Hackaday actually kind of gloms onto that a lot as well. Of like, and that was the other thing with LoRa as well. Like, so a lot of the LoRaWAN stuff, it's just like you can't beat the price. And when you have that, you have a wide range of people who are accessible to it. They can actually purchase it. There's almost no barrier because it is so low cost. And then you get a lot of innovation just purely from that low end side of things. I'm wondering if that's also the PCB motor thing. So you're basically opening up a new market by having low cost PCB manufacturing, that you just have more creativity within that.
I think absolutely. I mean, we were trying for years and years to add Wi-Fi to everything, and it was really hard.
Yeah, right.
It was either really hard or really expensive, or both.
Yeah, right.
And then all of a sudden, this chip that no one had ever heard of, that had a data sheet that could only be read by native Chinese speakers, popped out, and everyone was like, "Can we get this?" You know, this whole
How do we do
community
this?
popped up and like got it translated, and that company has since come out with a follow-up product that a lot of people have been using. And basically, Wi-Fi is a solved problem at this point.
Well, I wouldn't say that, but it's a hell of a lot more accessible. And it's crazy now. Also, you see that spinning into, like I saw uBlocks uses an ESP32, and the Arduino Maker uses the ESP32, and all these other things are just like, oh, the new particle mesh chip.
I didn't know that.
Yeah, they're using. I think they are. Yeah, I think they're the one that has Wi-Fi and Bluetooth. That has a ESP32 and the NRF chip on it.
Yeah, now I remember.
I was so cheap, you know, like, and it's like, so what happens when everything all the cost of hardware goes down to zero?
Yeah, you know, like Juicero, right? You're familiar with Juicero?
When Ben Einstein was on the show last week? We talked about it.
I wish that every mechanical thing was engineered like that, right? Because I love to like look at it, but the truth is, that's not what we need. That's not what we're going for. And so really, like, good enough is good enough. And with the Espressive chip, if you're putting out something that needs a really beefy processor and has like, you know, just needs to be really super dependable, that's probably not the thing that you're going with.
Go and pay someone a lot of money to make a thing that will be very, like, like the routers, who are the guys that make those crazy routers.
But if you need, you know, something that has connectivity in it and is going to do the job in large volume at a low price, like a solved problem, right?
Right. Yeah, that's true. Yeah. Yeah, it's like at least a default starting point, and that's kind of what. And then there might be other competitors that pop up to serve that market too. Yeah,
you prove your concept until you hit your constraint, and you say, "Oh, I guess I can't do it with this," and then you go through the pain of porting your stack to something else.
That was a mistake. Yeah, that's true.
Maybe you should start high and go low.
Right. I don't know. It's curious too, because that's like, well, you know, people hear me talk about the innovator's dilemma on here. That's like Clay Christensen book that kind of talks about that a lot of the innovation comes from the bottom up. You know, like you see people, like all the car manufacturers that start with the super, like Kia, right? It was a super low cost manufacturer, Honda as well, and then they just rise up from there. And I think a lot of it's just that volume of moving parts, moving stuff through. hitting safety standards, whatever. So these topics of low-cost hardware and more accessible and building communities and learning from others, it kind of all leads us to badge life, which is kind of what we were talking about here. You made a badge this year, and
Yes.
And you are a purveyor of other badges and the badge culture. So why don't you tell me what you think it is?
What I think badge life is.
Yeah.
I think badge life is the art of spending way too much time and way too much money exercising your creative demons through hardware.
That is a great way to say it. Especially because as someone who, I think my last count was over 4 figures of hardware that I put into it and didn't get anything out of it.
You did not.
Yeah.
Oh, I'm into it for about $550.
That's not bad.
Yeah, it's not. When I told Amanda, she was surprised, but I think like okay with it. I mean, it could have gone worse. Yeah, it definitely.
It well, and I think that people listening who are hardware people are not going to blink an eye at like thousands of dollars. It's just like, why are you doing that? I think that ultimately that's the real question. Why are you doing that?
Yeah, so first of all, I'm doing it as a thank you to badge makers who have just given me free badges for the last like 4 years.
Right.
You know, I'd like to go back to that DEF CON 22 that we were at, and you said you didn't have a great time, but I had a great time.
Yeah.
Like one of the first days, I just ran into these like 5 guys who had these big skull and crossbones, white silk screen with blinky LEDs all over it, and I was like, what is that?
What is going on
here?
here?
Yeah, because it wasn't the official badge. You know, I'd already been playing with the official badge, and it was a ton of fun. And these were the Whiskey Pirates, and they're like, come up to our room. And then I went up, and it was like, I thought it was going to be like the Michael Scott, you know, hotel episode where you go in and it's
it's like flashing lights and just like, there's a bar over there, there's apple schnapps.
They brought in like a stand-up pay telephone. They had a stand-up coin-op machine. They had a complete rework station. I mean, there's just like stuff everywhere. And they're like, do you know how to solder surface mount LEDs? And I'm like, yeah. And they're like, can you populate a few of these badges? And I'm like, sure. And so we just sat there with the music on. There were like 7 or 8 people like populating these badges. And I had a really great time with it, and you know, like ran an article on it. And I think like the next year, I pulled it out and like did a video preview of it. And I think that's how I got connected with the Anod guys the next year. Is I did the video, and then they're like, hey, do you want to have an early look at this badge? And I would like to put in a plug here. Hackaday respects press embargoes, and we love to get our hands on awesome hardware ahead of time. So go ahead and
cuts down anything to do at the conference, honestly.
Yeah, and just, you know, I don't want to be under a really tight deadline for turning around great content. So like Brian Benchoff and I got a hold of the badge on Thursday morning, and then it was like we were standing at the Circle Bar down right outside of the DEF CON entrance, like on the Wi-Fi or on the cellular hotspots, like trying to get images uploaded because the bandwidth is horrible, the spectrum's horrible, and get an article out, you know, like by 1 p.m. the day that the badges were released. I don't know, maybe I can beg DEF CON next year for an early look, but I doubt it.
Yeah, I doubt it too. Yeah, and so I mean, like, I've been trying to explain it, like I think on the show and just elsewhere too, and I kind of got sucked in. I don't know why I like it. I'm not sure if I like it. There's money involved now.
Yeah.
And I think that there's been pushback from people like, oh, well, people are like making tons of money on it. It's like, it's like the lowest paid work you can pretty much do.
I think that's revenue. Like they're making tons of revenue on it.
I think that is the confusion. So like, and I think the reason I like it is that I get to talk to people who are doing low volume manufacturing, who are doing it coming from different spots or coming from the software world often. They're doing creative things for no good reason, right? But like there's some really cool things in there, right? I mean, we've seen some of the things. Well, I'm sure that people can go and read your articles about DEF CON and the badges that are there, but there's just creativity, and it's kind of just for funsies, you know?
Yeah, and I had been involved with the Hackaday badges for conferences for the last few years, but it was mostly but it's mostly like a herding cats. I think you were much more into the hardware, like sourcing.
I was helping
dealing with sourcing problems. Like I didn't really deal with any of the sourcing problems. I didn't deal with the hardware design stuff. I like ported some games and you know maybe did some menus. And so I was like, you know what? I kind of want to do all of that. So this year on like July 1st, I'm like, you know what? I have a couple hours. It's a Sunday afternoon. I have an idea. Let's lay out a circuit and see where it goes. And then it was mayhem for like the next 3 weeks, and you know,
and beyond.
Yeah, Amanda would go to bed at like 10:30, and I'd be like, oh, I'll be there in like an hour, and then like 5 hours later, I'd be like, oh, it's 3:30 in the morning. Let me put this PCB order in before I go to bed. And but it, you know, despite that, it was a ton of fun. Like just encountering, I really like encountering new problems and new puzzles in that, and then also like learning the stuff that I should have learned before, like PCB or plane stitching, via stitching in KiCad, which I ended up finding your tutorial, and then I was like, it's 3 in the morning, I'm not following this guide, I'm doing it the wrong way. But I hear that's fixed in KiCad 5.
5.0. Yeah. It's a new thing.
Yeah, so I'm excited about that. I routed buttons wrong, so I routed to the 2 permanently connected parts of the momentary push switch.
Oh, jeez, yeah.
But other than that, I didn't make any PCB errors.
Good.
I was
well,
so.
Let's talk about the badge real quick.
Oh, yeah.
So, like, what is your badge?
My badge is called the Coin-Op badge. It's whenever I see Galaga, or Galaga as some people say, I have this visceral reaction. My brain just goes, "You should go play that." Like it's a totally fun game.
Do you have any quarters on you? Yeah,
yeah.
You have quarters. We could do this. We got time.
So I was like, you know, I kind of want to do the ship from Galaga because it's awesome.
Yeah.
And it's also, I don't have great art chops, and so it's just pixels, and I can definitely do just pixels.
Blocky.
That,
it looks like a ship. Yeah.
Yeah, and so I'm like, all right, I looked it up. It's mostly white. It's got some red and blue on there. I'm like, perfect. I'll do white solder mask and then put red and blue LEDs on there. I designed the circuit first, and then picked out footprints based on, I wanted a TQFP that was at least 32 pins, and so that set the size for the badge. I think each pixel is 6 millimeters on it. It ends up being 90 millimeters by 96 millimeters. It's got the cutouts for it, and then just runs off of a coin cell on the back, which is the other part of the Coin-Op play on words.
Yeah, that's great. That's awesome. Yeah, and it's well, you said it's at Mega, right?
Yeah,
like
so I went on DigiKey and just narrowed things down by that TQFP so I could solder it.
I got it.
And then 32 pins because I wanted direct drive. I wanted 32 pins or more.
Oh, I see. And to get that number of LEDs.
Yeah, and so I found an Atmega 48 that's automotive, and the SKU is obsolete. So I got the parts for 52 cents a piece.
Nice.
Which was one mistake that I made because the 4K of programming space ran out pretty quickly. I think I could have done with a little more speed than the 8 megahertz internal oscillator. So I think if I were to do it again, I would have paid $1 more per board. I made 59 of them, so we're talking about a $60 choice to not have dealt with programming space, which bit me a couple times. Right,
but maybe it also saved you. Like you're like, all right, well, you get to the end. You can only do so much with the programming. You're like, oh, I'm done.
Yeah, there are some things, like I had a I'm really proud of my power down sequence, which puts it into low power sleep mode. I measured it like 0.1 microamps.
Are you going to post a video of it anywhere maybe?
Oh yeah, I have video. I have a time lapse of the assembly process too, which I think is pretty cool.
Okay.
I did record it like me speaking about the features and stuff, but I haven't edited yet.
Okay.
Maybe
by the time.
Yeah.
We'll get it up eventually, hopefully.
Yeah, but what were we talking about? Oh. The low power sleep mode had a bug. So when the badge is asleep, it's looking for a pin change interrupt. I have pull down resistors, and then the buttons are connected to VCC so that you're not burning a pull up resistor while it's off.
Yep.
And the AVRs don't have a pull down resistor internally like an ARM would.
Yeah.
So, but when you first press that, I don't want it so that if you put it in your bag, it's just going to turn on. So there's like a confirmation power-up sequence, and it's a while one loop, and it's just looking for a button up or a button repeat from the debounce sequence.
Right.
And it appears in the first rev of firmware, I'd somehow get into that loop. So I think maybe static electricity was causing a pin change interrupt.
Oh.
But then or something. It's hard to replicate this, but it would be like
you need to make a bag testing chamber.
Well, it's like when you set it on a desk, I can't get it to happen, but when I put it on a lanyard around and I can walk around, it happens. And the problem is when I went to fix the bug, I was out of program space, so I had to optimize my code to fit the bug fix on there. But I also would have had time to do things like when you first put the battery in, it should give you an indication of what rev of the firmware you have, and I didn't have room for that. That kind of stuff.
Right. So that's the thing I really like about the projects you do. You like these low level. You like getting in the registers. You like writing all that low level firmware. I remember the 1-bit Pac-Man. That was
Oh, yeah,
that was a
yeah.
favorite of mine that you did.
That one wasn't very low though. So 1 pixel Pac-Man was fun. The low thing you're thinking on that is I looked at like cell phones. I'm like, no one can beat a cell phone screen. Like
Right,
it's
right.
they're
The
just so
resolution, yeah.
amazing. So I'm like, if you're gonna build a project and put like a crappy little 2.4-inch
Right.
TFT that's not very bright on there, everyone's gonna be like, this thing sucks compared to my cell phone. But then that Smart Matrix came out, which was using those commodity panels, 32 by 32 RGB LEDs, run by Teensy 3.2, which is Paul Stoffridgen's board that has a ton of great like DMA code for driving those LEDs. And I'm like, I wonder how many tiles classic coin-op games have.
Oh.
And so Pac-Man has less than 32 by 32. It's like 30 by 26 or something.
Oh, really? Oh, wow.
Yeah, and so I'm like, the entire Pac-Man game can be represented on this if you just don't make the sprites.
Don't add detail.
Yeah, and so like the walls are a blue dot,
Yep.
and the pips are like a white dot, and Pac-Man's yellow, and the
I never knew that's what they're called. The pips are the things you eat.
I think they're called pips.
Oh, I didn't know.
Yeah.
I didn't know.
Well, it's like what's on a die, right? Pips on a die. Maybe they're pellets, because the big ones are power pellets.
Oh, okay.
All right.
I'm not like arguing any of these things. I just didn't know.
So this might be getting a little too far off of Amp Hour fare, but the AI in Pac-Man
No, I think this is fun. You've told us.
fantastic. So it's moved around, like the website got bought, but there's something called the Pac-Man dossier, and it's got the reverse engineered rules of all the AI from the original ROM.
Right.
And it's fascinating, and it totally ruins the game for you.
Right, because you then start to see the code, right?
Yeah,
Right.
yeah, but it like.
Well, it's done with like logic chips, though, right?
Yeah, and so what it is each ghost, every time they get to an intersection, is making a choice on whether they should turn right, left, or go straight. And then what they're trying to do is
we should say spoilers. So if you're a big Pac-Man aficionado,
don't listen to this next part.
Right.
But they basically just set a coordinate that the ghost is trying to get to, and it says if I turn left or right or go straight, is it going to be the shortest route?
Yeah.
And then in order to make them look like they're actually doing something, when they're chasing after you, some of them are like.
It's based on the color, right? Like they have different names.
Yeah,
Blinky,
Inky, Pinky, Blinky, and Bartholomew. I'm pretty sure it is. So I think it's Dot. I think the last one's Dot. But like the red one, Blinky, let's say, is actually chasing you. But another one is chasing like 5 points in front of you, and another one is chasing like the reflected angle of you and stuff. Like it's really simple math tricks, but when you stack them all together, it becomes like a really interesting thing that tricks your brain into thinking you're seeing like intelligent
smart.
behavior.
Yeah, right. Yeah, algorithms and stuff.
Yeah, that was a really fun project. The only thing I didn't get to do was add music.
Oh, right.
And that would have been perfect. Someday.
Still time.
Yeah.
Still time.
Yeah, add it to the bucket list.
Yeah, right, of course. Just add it to the bucket.
Yeah, that one was frustrating because, the libraries for the screen were already in place, and they're using the Arduino IDE. And I like to write in C, and I have like libraries of things that I go back to in C, and it's a real pain in the butt to include your C files in like a multi-file Arduino project.
Right.
And I recently did it again. I had built a Blinky hat for DEF CON 22, the first one that we went to.
That was the hackable hat, right?
Yeah, and I actually brought it. It's in my hotel room. I haven't busted it out yet. But that was like WS2812 strips, and I built it in a super short period of time. And I needed connectivity to a real small Wi-Fi router.
Yeah.
And so I ended up going with an Arduino board because it's got USB, and you can plug it into a router. Router's running OpenWart, which has like Linux, so you can like cat or echo commands to the board. And I went to build a new version of that hat this year because LED technology has come so far.
Sure.
And so I started writing the software before these flexible LED panels came. I got 8 by 16 RGB LED panels. I got 4 of them, so 1,000 of these great super bright LEDs for like $80 delivered. It was amazing.
Yeah.
Yeah, so I got these panels to make a new hat. And so I started to pull that software out again, and I went through like the exact same problems I had before with putting libraries into it.
Again, this is Arduino IDE.
Yeah, so with this hat, it's so many LEDs that I don't want to deal with having to push out the communications. And the price was because these are 2812s. They weren't the APA 102s, which I think are a little more fun to work with. And so I wanted, Paul has another library, Paul Stoffergen, the TT 3.6, has a library called Octo 2812, I believe, that's using, again, DMA to push out basically a frame buffer to these. So you don't have to deal with the speed problems that you would normally have. It's a really good way to write for it. The problem that I ran into is I didn't think about quiescent current.
Oh, yeah.
And it's like 900 milliamps when all of these are off. And
when they're off?
Yeah, when you're not even showing any LEDs. It's 1,000 LEDs. It'd be cut down, I think, to like 880 for the circumference of the hat.
Right.
But I really believe if you're going to build a blinky hat to wear around, everything's got to be inside the hat. You can't have like a cord going down to your backpack. It ruins it. You might as well make a backpack that's got lights on it.
Right, and then it like looks like a Ghostbuster pack.
Yeah, so then I started looking into like how I'm going to supply current for this whole thing, and I'm like looking at drone batteries and like how I'm going to regulate that, and I'm like, I might need active cooling, and I'm like,
you're going to need a sprinkler system for when your hat starts on fire.
Yeah, I'm like, I don't want to burn my hair off. And then of course, if you have active cooling, it means you have a fan. I'm like, if you have a hat with a fan in it, you need a smoke machine, because you got to have smoke coming out of it.
And this is how it all starts.
Yeah, so maybe next year, that's when I kind of like swapped priorities and started with the badge.
You could do like they just sell these vaping people. You could get some vape fluid.
Actually, that's a really good idea for a smoke machine, is to break down a vaporizer. Yeah, have you seen that done before?
Oh, I was just thinking, that's where you see tons of smoke these days, especially, so I'm not used to Vegas style, like everybody's smoking, everybody's using vape stuff, and it's just like, oh my God.
Yeah, I don't know if it's a Vegas thing or a DEF CON thing.
Maybe it's just whatever the crowd is. I don't know. I'm not around that much. So.
Yeah, but that would be a great source because it's already portable power supply, portable heating element.
Might be a little battery.
Yeah. Well, thank you.
Let's talk about so you mentioned the Arduino ID, and I mean you're interested in the low-level C stuff. Anyways, this is a topic that comes up on Hackaday a lot, of like Arduino, and like, like it's kind of like when you welcome people in the community and stuff too, it's like sometimes there's pushback on that stuff. I mean, what do you see as the editor of Hackaday of, around that? You're pushing out articles all the time of somewhere between beginner and advanced, and like, how people react, and we don't need to talk about the comment section, but
Well, I think just generally as an editor, it's great because it kind of gives people a thing that they can look for. Like if you're like getting into embedded and you're like, oh, which chip do I use? Like the Arduino name it's a brand, it's a movement, it's it's a compatibility layer. It's kind of like a catch-all that means like blinking stuff with a microcontroller.
Right. Simpler than it would be otherwise, right?
Yeah, and so I think it's a really good way to kind of just say this is the kind of general cloud of topics that's going to be discussed in this article, or this set of articles. So I think that's really good because people who don't know what they don't know can actually find their way in. Whereas if you run an article that's like,
SGM32, F40, or F401, right?
Yeah, exactly. And actually what we've seen is like the ESP8266 is like the same sort of thing. So we have a lot of people that are coming in, like looking for like, okay, I have this thing, I got it to do one specific thing, what else can I do? And that's one of the places that people use Hackaday a ton, is like the kind of like new ideas and like things that didn't work but were kind of cool. Right. You can often unearth them there.
Yeah. So it's almost like the mimetic thing again. It's like you're kind of just following the scent of like, well, maybe this is next, maybe that's next, this is of interest, that kind of thing.
Yeah, I really think the badge life thing is kind of indicating the next thing, and I compare it to Arduino.
Oh, that's interesting.
So like Arduino, before Arduino came along, kind of the precursor to Arduino is like programmers and compilers started becoming more widely available. And so you started to have this influx of people that were like actually doing things. Like for instance, guy with a couple of music degrees playing in 2 orchestras, Mike Szczys, was like, hey, I want to try program some microcontrollers. Oh, I can afford some ATT13s, and then I can build a DAPA programming cable with like 2 resistors and some ribbon cable. And that's actually how I started, and I like immediately bricked one of those chips, and then like 6 months later ordered a proper programmer. But it's like that path where it was accessible, the information was there, the tools were pretty cheap, was open to me. So I think with Badge Life, especially this year, they have the add-on standard, which is called the shitty add-on standard, which is unfortunate, but
silly add-on standard.
Yeah. I'm gonna do the superb add-on standard for next year.
Right.
But I think that is people who are like looking at badges and are like, I really want to do that. I don't have time to build a big puzzle and like figure out the protocol for like a parallel TFT display and stuff like that. You can be like, oh no, I'm just going to make a creative badge and lay it out as a circuit board and solder on some parts, and that gives them the the skill of like, what does it take to export Gerber files, and how do you find the fab that you're going to have doing it, and how do you make sure you get your footprints on the right side of the board with the right orientation? Like,
again, easier in 5.0. We'll see. And actually, a ton of I've been really happy too, and I think this might be another reason that I'm particularly biased for badge life stuff, is like a lot of KiCad users. It's great.
I'm a KiCad person myself. People can use whatever they want, but it does make me feel good to see people giving it a try.
Yeah, exactly.
But it's like people might decide after they've used KiCad, like they just download it because it's available right now, that like, oh, I've heard about Eagle or Circuit Studio or Altium is a big beginner tool, I hear.
Yeah, right. I just had this pile of money sitting around.
Yeah, I don't really care what people use. I think it's gatekeeping. So you're asking about what do people think about Arduino? So the people that don't know, on Hackaday for years we'd run an Arduino project and people like Arduino.
Right.
I don't particularly care for the IDE, but I don't care for any IDE. I generally like to use a text editor and type make into the command line.
Oh man, he's one of those.
I am sometimes, and I'm not other times. Like I use the MP Lab for the Hackaday badges. That's a PIC 32, and like that comes with its own set of problems.
Sure, of course.
But it allows you to do things like navigate by function, which if you're just scrolling in a text editor, once you get to about 1,000 lines, that gets old really quick.
So I just had something pop in my head of like Mr. Meeseeks like screaming like, "Technology is pain."
Everything is pain, Mr. Meeseeks.
Like, right, yeah. I mean, that's what it comes down to, though. It's like, so and that's what made me switch over, from being not a Hackaday commenter, but someone who was like, oh, whatever. But it's like, whatever works, just get more people in the door. That's all that matters,
Yeah.
And I think that that's good for Badge Life and DEF CON and all this stuff, and just seeing where it happens. So.
Yeah, and with everything, we're talking about the Hackaday Prize before, and I look at the projects that are coming in, and I look at some of the really young competitors. Anyone that's 13 years old or older can enter, and I'm like, what's going to happen when these people are like 30 years old and start to like run engineering teams? Like, it is so
You think
incredible.
It'll take that long?
Yeah, probably. I mean, they're probably founding companies.
Right.
You had Sam on, Sam Zaloof, right?
Yeah,
and so Sam Zaloof's the guy who did lithographically produced integrated circuit, like in his garage, basically.
Yep.
And I'm like, the fact that you can go out and get enough like used equipment and enough knowledge and like access to the chemicals, and then the fact that we have this structure set up to like celebrate these people on the Amp Hour or on Hackaday or anywhere.
Just generally YouTube as well, right?
It is just a great time to be
There's
alive.
A lot of, I mean, let's say it like it is. There's a lot of crap on the internet, right? There's a lot of bad stuff out there these days. However, I think that like this is the shining light kind of stuff of like makers like Sam and just people doing. Ben Krasno, someone I always hold up as like where the hell that guy come from? Like, and it's just great though, right? And I think that usually my first reaction is I'm not doing enough. I'm not doing, like that kind of like stress of like, oh man. But like once you get past that, I think when you like really just start to like be like, oh, that's awesome. If you can just have that, oh, that's awesome reaction, and then be like, I wonder if I could use that. Stick that in the library of your brain, and then pull it back out and go back to the Hackaday article later. That's really helpful, I think.
Yeah, I think a few things about that. I mean, first of all, you're always watching someone else's highlight reel.
Of course. Yeah, that's a great reminder. Yep.
It is. It's really tough. My brain has trouble like learning that lesson, and I often compare myself to the snippets I see of Ben Krasno.
But also like Badge Life too, right? We see a lot of people that are just like selling these finished pieces of art that are like, and they're just, hey, it's this thing. It's like the Bender badge was the N.XOR, the DC26 Bender badge, which is amazing art and all those stuff, and we talked to the team, we know them. Like that's 6 people doing like I've talked to them at 1, 2 in the morning.
Yeah.
It's a lot of work, so yeah.
Yeah, I'd encourage people to go look at my review of that badge for this year, because I psychoanalyzed the team based on the art that they've done for their badges over the last 3 years.
Oh, yeah, that's right. You said the progression is things get more worn out, right?
Yeah, like half of Bender's face is like falling off at this point. I'm like, that's the stress of Badge Life.
Right.
But I mean, really, They have, so you mentioned before there's a lot of money in it. So there's a lot of money in it for people who are making a lot of badges. Like it costs a lot to, order that many components.
Right.
It costs a
A
lot
lot of
to,
cash flow.
yeah,
right?
to set up a contract manufacturer and that sort of thing. I believe their Kickstarter was $47,000. There's a lot of accountability there.
Yeah.
And if you have, I don't know how many they had. Let's say they brought 400 badges to the conference or whatever. Like you have to sell those.
Yeah.
Like there's a lot of inventory locked up there. I don't want that at all.
Exactly.
Yeah.
Well, and that's the other thing is that like knowing the people we do, like some people are here like working the whole time, and like and so I will give the update on my badge. My badge, I didn't finish it. I didn't. I mean, I got the hardware done. Mike, and we should talk about the assembly piece, right?
Yeah,
but like,
yeah, that was good.
But I just didn't get to the firmware in time. I had a lot of stuff going on. It's like nope. I could have been sitting in my room writing code the whole time. I don't want to do that, right? Or I could have been sitting and soldering the whole time. I don't want to do that. I want to meet people. I want to be here. I want to be present.
So I met Chris at the bar just before dinner last night, and he had his badge out, and I'm like, "Hey, Chris, like, is it blinking?" And he said, "No," and I'm like, "Well, like, show me your code. I'll write some visualizations for you. I bet I can do that right now. It'd be great." And I said, "Do you have a heartbeat yet?" No heartbeat at all on that badge. I think that's awesome.
It's a cradle death.
Yeah. But you have an LED driver on your badge. It's a Charlie Plexed LED driver, right?
Yeah.
So my number one tip on a situation like that is always connect a single LED to a single pin, so that you can get your 1-bit debugging code out of that. Because getting the protocols on those chips up and running, I don't want to.
A lot of libraries and stuff.
Yeah, I don't want to be analyzing the signals with an oscilloscope unless I absolutely have to. I just want to, get some iteration and be like, am I sending when I think I'm sending, and that sort of stuff.
Yeah.
But yeah, I think that by and large, it's a small number of people who are doing a huge number of badges.
Yeah.
And I think that the community spirit is still really strong and still growing of, let's do something creative. I set out to do 59 badges. Like I gave away half of them to people like almost within the first 2 days. Oftentimes they're like, yeah, here you have my badge. Like just kind of showing off what you were able to build, and then like telling those stories about routing the buttons wrong or making not being able to do a fix in your power down because you don't have code space,
right?
And just kind of hearing what went wrong with other people's badges, and then like where that inspiration for each of them came from.
Yeah, it's trading stories, that kind of thing.
Yeah.
Well, and you were super generous, and you came to Chicago and on a weekend and helped me relearn the pick and place together. So the NeoDen 4 pick and place that's out of my workspace, that was one of my goals for like doing all this and having a god awful amount of LEDs, is to learn that process, right? So.
Oh yeah, and I'm glad you did. I kind of had this epiphany earlier in the year that I'm like, I've always thought to myself, I'd love to be an embedded engineer. And I think I was talking to you, and you were like, well, why don't you spend some time and like get some of the skills that you've never done before.
Right.
So when you said you were going to do pick and place, I'm like, I'd love to come down and see that. I've never been involved in a pick and place process before. And do you say that thing's about $10,000?
Yeah, about 10,000. Right.
It's again just like this whole thing of like the next thing is availability of manufacturing.
Yeah, right. I hear there's another one that I forget the name of it, but there's another one that came out, and SparkFun has. I think Nathan from SparkFun has one, and a couple other people I talked to here have them now. Really low cost, like $3,000.
Wow.
Pick and place, and it's So that's another one that's like. Again, like, so me and Dave have talked about it on the show a lot of like, should you have a pick and place? There was a Joe Menard talk at HDDG, which is a supply frame thing that I point people to a lot of, like, don't do pick and place, right? But I think at the end of the day, the accessibility of electronics in general, specifically badge life, but other things as well, it's like, well, maybe it is getting to the point where if there's a market for it, if you have the need to make enough stuff, maybe it is worth the time to do your own things.
Well, I think you have it figured out. So what you should do, if you can, is find a co-working space that has one.
Oh yeah, versus buying your own. Yeah, totally.
Yeah, and spec it out. Also, that lets you figure out if you want to get the $10,000 one or if you want to get
right. As your business grows and you want to build your own, and
but I got to say, when we turn that machine on and it starts moving around, it's like, whoa.
Yeah.
It's just amazing. And like, I know from having looked at it before that they have a downward pointing camera and an upward pointing camera, but until you actually see it on the screen and you're like clicking around to move it.
Right.
Probably the most delightful thing was we put a test capacitor on, and it like we had the offset wrong, and it tried to put it in a mounting hole, and so we had this capacitor like on end in the mounting hole showing on the like macro view.
Right.
And I'm like, that was so awesome.
Yeah.
We did get it working. It only took 6 hours, and almost lost our lives to lithium.
Oh yeah, that's true.
Lithium
Yeah, I
battery
don't know if I mentioned in the show yet. We had a battery go off, right? But there was
Not someone.
We didn't do it, but yeah, someone was working on lithium-ion batteries while we were trying to get this thing done. We're already stressed from that, and someone punctured a link to the lithium-ion. They were closing a case which had it, and this thing started sparking and letting off and off-gassing, and just
it was like a Roman candle. I mean, it was
scared
like
the shit out of me.
Yeah.
I had not run. I think I told you this too. I've never run for my life before. That was the first time I've ever run for my life.
You have good instincts, Chris.
Actually,
you don't, because you said you froze, right?
I first froze, and then you don't know what it is at first.
No, I thought that I thought it was like
it was a joke.
compressed air.
Yeah,
like,
right.
And then I saw the like the Roman candle, and I'm like, is someone grinding? And I'm like, no, this is bad.
Right,
like, get out.
Yeah. Danger, Will Robinson. Danger. Yeah, right. Yeah.
Yeah. But using the pick and place, I thought the company had YouTube video tutorials. Which were
not bad, right?
No, they like walked through the parts that you needed to walk through.
That's okay. What's up?
Of course, yeah.
Yeah. Sorry. That's okay.
The company that makes the Neoden 4 had tutorial videos, and they basically had the parts that you needed to do shown off pretty well. They didn't go into every detail.
Right.
And that became really an issue with the offsets. Like, we got the file format for it figured out
so you wrote a Python script, and I'll be posting, well, we'll post that somewhere. But I ended up going back and making a video to show that, like, at some point you just need like a start to finish, just show me how you're doing it, and that's what I've ended up recording, and hopefully I'll have that out.
Yeah, like KiCad will kick out everything you need in a position file, POS file,
right.
But it's not in the it's not in the format that the Neoden is it Neoden?
It's Neoden. Yeah.
It's not in the format that the Neoden needs. And there was weird stuff. We found like a blogspot page from last year or something.
Yeah, you're plumbing the depths of the internet just to see what Google's found. And
and that was the one that told us that KiCad does 0 to 359 degree rotation, but the Neoden does negative 180 to 180.
Right.
And so when you load your file, and it needs to be a CSV, when you load it in, it won't give you any error. It just won't do anything.
Right. That is so. And we should also mention the tutorials were okay. They really were, and a lot of people said they've also gotten it working from that. But honestly, I think the hardest thing is that this was a panelized design, and so taking it from one board, which I think is how a lot of people use it, they secure the board down, then they do it from there to the final working thing. That's where the translation didn't happen. I think also a lot of people come from Eagle, and there's a ULP script that helped with that. So just kind of at the end of the day, you're translating to this end format and not the other way around.
Yeah.
So so that script was good. You wrote. Ultimately, I think the thing that we finally figured out, like in the 8th hour and the 9th hour of working on this thing, was everything is, so everything is referred to that first component that's on your list, and or that's how they show it, at least in the videos. But then it was all about, like, you had to then give a relative measure to where your fiducials were, and that's the thing we could not figure out. Ultimately, that was from looking at someone else's files who had already used it. That's what helped.
And you have to do that in KiCad.
Yes.
So you have to set the origin in KiCad to match what that offset is going to be to the first component on your list.
Yeah. Right. So I had the first it was like R1 was the first component, or D1 I guess it was, because it was a diode. So D1 was the first component out of this huge array of LEDs that I was doing, and then it was like that was 0, 0. Everything was referenced to 0, 0. So like D2 was at 4 millimeters over, 1 millimeter down, and then you also had to say from 0, 0, where is the fiducial? The fiducial is over 60 millimeters to the right and 50 millimeters down. It would go and find that. It was like a circle, and then it would recognize that, and that's how it knew where everything was, because there was 4 per panel.
And they show you in those tutorials like how to set that fiducial, but they don't make the connection on what the importance of that is.
Right.
And like the labels on the interface do not make that clear.
And it's all, the fiducial is I think the thing that tripped me up most is that the fiducials are a relative measure, right? So it's going from 0, 0 to the fiducial on a single PCB on the panel. But the thing is, you could go and seek for it, right? So like one of the functions of a neodyne is you can click, it turns on the camera, and you can go and seek it around. Then it becomes an absolute, within this 400 by 400 millimeter space, you can then give it a coordinate, and that is not the way to do it. That's not what you want to do. So.
But we got it working, and it worked
Right.
great. The one thing that we didn't do is center the camera on the tray of LEDs.
Yes.
So there's a void on the LEDs, and you said that became a problem with the bottom of the board.
Bottom of the board was actually a totally different problem. So the nice thing, and the reason that I think this was a really good candidate and for if other people are doing it, if you're doing an array of LEDs, it's all the same component, right? If you're doing, I did three picks, 3 places, 3 picks, 3 places, 3 picks, and that went pretty fast. On the backside, now you have lots of different components. It was not calibrated for the different types of components. I had resistors, capacitors, all these different things, and then the pick heights were different. These are, I mean, we're literally repeating like things that, like we talked about education before, right? We're just trying to pass on the things that have already been learned. People are like, probably listening, like, well, why don't you just use like the manual, whatever, It's like, well, we're trying this new super low cost thing, so.
But I got to go back to the Arduino example again, like embedded programming, and then Arduino meant that like there's this wealth of knowledge that all of a sudden became available.
Right.
So if you're making a video about this and you're posting, a script that we had used, and then we found the Blogspot article, we're just like in the very trickle of information, and then at $10,000, it's kind of like the espressive thing. This is not the best pick and place by any means. No,
right.
But you know what? If you're in the badge life and you're just trying to get, 200 of your boards, populated or.
Yeah. Well, I think the big thing is that, so like out of this whole experience, I learned to pick and place. But the other thing that I've said coming out of this is, there's no reason for me never to panelize again, right? I will always panelize boards from now on because why wouldn't I, right? And just at least I have that option. If I don't, then I'm just putting my own parts onto a ridiculously large board, but who cares, right? And like that just changes my working flow, and that's something I've learned out of this as well. I don't know if you would do the same.
Oh, well, since I know you and I can drive a couple hours down to Chicago, I'm definitely going to panelize if I can.
I mean, so like as a comparison, right? You said you got, what was it, 4 boards done in how much time?
90 minutes.
Right. So.
And that's placing by hand with a hacked aquarium pump.
Right. And you made 60, so that's at least, so it's what, 15 times 90 minutes. That's like 45 hours, right? No, that's not right.
I think like 22
and
hours.
a half hours, right? Yeah.
At some point, I realized I had 22 hours of assembly ahead of me. So
and that's in a good time, right?
Yeah.
And so like if you could go and drive for 2 hours, I don't know,
2 hours, and run all the boards. Right. But also like I'm doing it in a toaster oven that doesn't have like a PID controller on it. And you at MHub had the pizza oven, it's a solder oven, but it like conveyors like a pizza.
It does
would.
look like it,
And that just did a great job of cooking those boards. This is the first time I've used a solder stencil.
Oh
and
okay.
I just did whatever KiCad spit out, and I had these really tiny 16-pin resistor arrays that are 1506 parts, and it bridged 100% of those.
Yeah, right. You've done a lot of your work.
Yeah, in my time-lapse assembly, you can see me with the solder wick on every board and the flux, and then cleaning the flux off and grinding my teeth the whole time.
Right. Yeah, it's been interesting, kind of like, so like you're talking about the pain of learning, I'm talking about the pain of learning, and some people kind of skip that step. Again, limiting it to the badge life crowd, like some of them went straight to assembly, and I think that might have been the right move for a lot of people. It's like you just skip that step and.
Well, let's step back. There's still pain in going straight to assembly.
That's
I mean,
true.
come on,
yeah. But I think in all these cases, right, it's all about that learning that next step, because the real thing I learned is, manufacturing sucks. Like I've always known that. It still sucks, and it's. Every time someone's like, I was talking to someone here at DEF CON, they're like, yeah, I brought a Volterra printer. Remember those?
That was huge one year at CES.
Yeah, right.
Like it was the sweetheart.
Yeah, it's cool, but like, anyways. I think that was like an attempt to solve the same problems, but it didn't, there still isn't, if it was going to get easier, it would have gotten easier already. And so there's still a lot of manufacturing issues, and just making things is hard, right? And even making software is hard, right? I mean,
I just wanted to know the stuff that you're not going to learn reading a recount of it, you know, like until you actually like.
That's a good point.
Yeah, until you burn your fingers on the solder wick, you know, 59 times.
Yeah, right.
You don't really know why you don't want to manually rework bridged components if you can avoid it.
Right. But that's now something where you would consider again before you make your next board, or.
Well, to tell you the truth, so I ordered 15 boards and then I ordered another 40 boards and I ended up getting 59 boards total. But if I hadn't had to like redo all the traces, I would have put a larger package on those other 40 boards. But at that point, I'm like, well, if none of these get assembled, it's fine. I don't have time right now. I kind of front-weighted my design process. So I think in about 10 days, I was staying up like till 2 or 3 in the morning, like every night, working on firmware, because I did have an Atmega 328 on hand that I could prototype with, and then go to the other chip. But once I had the first set of boards and I knew that it worked, I didn't really want to do like part changes for the other set. Right. Not just because of assembly time, but because I couldn't have done a third spin of boards before DEF CON.
Right. Time ran out.
Yeah.
Makes sense. Well, what about other? I guess I mean this is not one of the short episodes like I did at Tour Camp. This is pushing an hour already. But what are some of the other? You know, you mentioned that like the stuff that we see in badge life now will be are trends that are already in process, right?
Yeah.
So what are you as someone who has to cover all these things as well? What are some of the trends you're seeing?
Oh, geez, that's a question to put me on the spot, isn't it?
I can start you off.
Yeah, please do.
I saw ESP32s everywhere. You as well? I mean, I don't know. I saw, at least of the badges I've seen, it's 10 at least.
Yeah, why do you think that is?
Cheap processing. I would know this because I put that on mine. So like, I don't care about Wi-Fi. I don't care. Someone like left me a message like, you know, you have Wi-Fi on your thing. I'm like, I'm gonna turn it off. You know, like, it's $6 for a module that like is done, and then if I wanted to turn on Bluetooth and Wi-Fi, I can. And it's a dual core, you know, it's a power hog, but it's dual core, multi, you know, tons of peripherals, whatever. Like, that is something.
Yeah, so it runs really fast. I mean, I think you could go with like a Freescale chip and get a similar thing.
Yeah, but it's also big. It's bulky. You know what I mean? Like it's accessible. So you're not soldering down the chip itself. You're soldering down.
I would go the other route and say that the module is more of a pain to solder down than chips are.
I guess there were some issues with that, but
it just goes on what you're doing. Like, I like to be really close to the hardware, so I feel like I don't have a good understanding of the SDK for the ESP32 already.
That's true. Yeah.
And so like there's a pain barrier for me to get into it, and I haven't generally done stuff with Wi-Fi.
That's true. And you wouldn't want to do low-level code on like a dual core. With
no, and I'm more likely to do something, you know, hacky, like, oh, I want Wi-Fi in this project. I'm gonna put an ESP8266 as a secondary chip, and then, you know, use a UART to talk to it.
Yeah, right.
The other thing is, like, I'm always thinking about power and, you know, processing tightness. And I think when you go to those beefier chips, not just the ESP32, but like once you start to get to the bigger arms, you're relying on like peripheral libraries from the manufacturer, and I don't know what those are doing. I don't know how long it's going to take.
You don't trust anyone, huh?
Yeah, I have control issues. Yeah. Maybe I certainly have used those, but I know that if I'm going to go and use that, I have to give up on this ideal of like really tight things that work well that I'm going to be able to debug.
Right. Okay. So, all right. So
trends, you know, I don't see huge hardware trends right now. The trends that I see are in like leveraging tools that work with a lot of data. So I think like people that are using like TensorFlow and trying to get into
badges, or are you
no,
saying
no,
more
no,
generally?
no.
Oh, okay.
You're just saying like I see trend
yeah,
stuff.
Trends in general. Okay, I was saying on badges, but yeah, more generally, trends are interesting too.
Oh.
You see this as obviously you've seen tons of stuff coming to the Hackaday blog, and you know what gets submitted.
Yeah, it's a crazy amount of things that are coming through. But I think you know, TensorFlow just put out like officially supported binary for Raspberry Pi, which is I think a big development. My issue is, and this is maybe going to make me sound really stupid, I haven't seen any compelling uses of neural networks.
I believe I just saw the other day a robot that finds Waldo for you.
I saw that one. Yeah. That hand was very specific on where Waldo was going to be. No, I think that I see neural network things that are doing things faster than we would have been able to do in the past, but I'm not fundamentally seeing things that immediately make me go like, oh,
The
neural
future has
networks.
arrived.
Yeah,
Right.
and so I think if you want to go back to badges and back to embedded, I'm really optimistic that we're going to be able to use training sets to really increase what we can do with small microcontrollers by
like-
preloading the training.
It's like OpenCV on microcontrollers?
Not necessarily OpenCV, because you generally need a lot of processing power to deal
Right,
with
memory
video,
and-
and
right, yeah.
but it's more like like batteries are not really getting better,
It's true. They are on a linear path, whereas everything
right.
else is on a different one.
But chips and chip makers seem to be doing really well on getting to be lower and lower and lower power. So I think we're going to see a really big push to take high computing power stuff that has a lot of power and find a way to optimize it to work on the really low power chips so that we can get around the battery problem of portables.
Got it. So almost like how the prevalence of cell phones drove the growth of Class D amplifiers, because you can't be running a Class A, well, not even Class AB amplifier on a cell phone, because why would you, right? The
Yeah.
sound quality is good enough with Class D, and obviously it's still pretty good, and SIPs current effectively for what it is.
Yeah. So the uses are out there somewhere, and I like to see people doing simple things that don't push those boundaries, but teach them about what is machine learning, what are we doing with these data sets, and because again, if you fast forward, if it's like a 16-year-old in high school who's really into this has a lot more time than a 21-year-old engineering student who has other things going on, and so
30-plus-year-old engineer with a family,
yeah,
right?
maybe. I mean, once you kind of get settled into your job and you start to be able to handle it, I think the curve goes back and you get a little bit more time. But at that point, you have maybe other priorities in your life, like, oh, I went through college and I didn't do all this other stuff, and now I want to have a family and take vacation, that sort of thing.
Right.
I really look at the teenagers that are in high school and I'm like, can we get them to look at doing engineering things as their hobby instead of playing video games or something that's not quite as creative. I love video games. It's a great outlet, but I think the people who are spending their time and staying up too late and like doing this like self-learning thing in their mid-teens, they're the ones that are going to end up being really driven, because they get to college and it's not like the first time where they've had to do labs and stuff. They've been doing it the whole time. Yeah. I think they just end up with a big head start. And so if we can get younger and younger people, like that gateway drug of Raspberry Pi, to get into like neural networks, the killer thing that can come, I think that's one path to it.
Got it.
I should also say, I feel like I'm being unfair. We were on an article a couple of years ago, I think Cameron Coward wrote it, where he had interviewed a couple of people that are like serious AI researchers. And one of the things that they said is that we keep moving the goalposts on artificial intelligence.
Right.
As soon as we do something interesting, it's so obvious that everyone looks at it and says, well, of course it should do that.
Of course
but
you
now
have
it
a
should do
thing
this.
sitting on your kitchen counter that listens to you all the time and starts playing Spotify for you.
I totally get that, and I still do it anyway.
Yeah, of course. What have you done for me lately?
Yeah, exactly.
Yeah, okay. So trend-wise, though, it's more broad-based of like these, like you said, data set.
I think so. That's the things that when I see it, I'm like, whoa, that stuff's really going fast, and we're getting a lot of new activity there.
Yeah, I mean, I'm curious too about again, to bring it back to the badge life stuff, I guess, is like, people doing hardware and getting into hardware are very software focused, and I'm always they're usually software people that are doing hardware to learn or for fun or whatever, and I'm very curious about what that's going to do from a trends perspective of, like, I mean, I use Git for all my hardware stuff now, right? Wasn't doing that 5-6 years ago, and I think it was the influence of people that were software focused that just brought that to my attention. And I'm like, oh, that's a good idea, right? Not saying it didn't exist before that, but I'm just saying that that's my personal experience with it. And I wonder what other trends are going to happen there as well.
Well, that's a good point. I see a lot of MicroPython.
Oh, that's true.
And
right.
I see people doing like serious stuff with MicroPython.
Yeah.
And again, I like the low level stuff, but like I had a 1-bitsy that you could flash MicroPython onto, and I did it, and I was like, I got in there to the interpreter prompt, like you serial into
the REBL,
it.
Yeah,
and then like you can type help, and it'll like tell you like what the pin mappings are.
Yeah.
And you don't have to like look it up, and I'm like, wow, that's actually like
flow of endorphins.
Yeah, if you don't need a really tight timing for something, and you're just trying to make things happen when they should happen, and you're just trying to get something hammered out really quick, which is how I use Python anyway.
Right.
I use Python that's what I use for the Neoden.
Oh yeah, right.
I use a lot of text manipulation. Yeah. And like if we're doing an article and I need to put like 20 bullet points that have a title and link in them into HTML, like I will not cut and paste that. I'll generally like just script it in Python really quick and then cut and paste the HTML in. And I think the ability to do like rapid prototyping on hardware like that, especially for people who are already really comfortable using APIs and looking up references, that is another gateway drug for getting to hardware. And I think innately everyone wants to be into hardware. Like, who doesn't think a smartphone is awesome? But it's a black box for most people. And so once you start to pull back that curtain, then they're like, I didn't even know I could do this. Like, what else can I do?
Right. Yeah, it's going to be interesting to see how that stuff changes over. I think the accessibility thing and making hardware more accessible, there's still going to be some barriers. He says as he has a KiCad hat balancing on his knee, but
this is why it's coming, like you said, from software into hardware. Is like everyone has a laptop. If you're working in any kind of engineering type of field, you have a computer available to you, and so doing software stuff is the first thing you do, because once you have the computer, there's really nothing else. An internet connection is really what you need. But with hardware, you got to have a bunch of gear. Even at its most simple, you got to have a USB to serial cable and some type of breakout board and some type of power supply. Or I guess they do make USB dev boards that's really all you need, but it's still something else. And then if you've never bought a bare board before, like picking out which one you're gonna do, like there's a barrier there.
Yeah, it's kind of like how do you get started into that, and is it friendly enough for people to be welcomed in? That kind of thing.
And then people are like, we need to be teaching this in school. I think that's really tough to
blanket statements are always tough.
So I don't think you're ever really going to get over that. I think what you're going to do is you're going to have so many examples that are like, ooh, candy, type of experience, that then you start to attract towards the people. Like a $5 Raspberry Pi Zero, like that's pretty incredible. And then people are like, oh, I can play video games on this. But then at some point, someone's like, oh, I can hook up lights and then blink the lights. And then when you start looking, eventually you get people are like, oh, GPIO on Raspberry Pi is actually kind of janky. You should try X, Y, or Z. Kind of go from there.
Yeah. Well, it's exciting. I mean, I saw someone wearing you talked about your hackable hat. I saw another version of a hackable hat. It had a Raspberry Pi on there. It's just an access point broadcasting. It's like, come hack the hat, So it does open up those new things, and it is interesting to see when that happens. What are some other? So I guess as last things, what is something you wish you could share about DEF CON specifically with people, so that they might think about coming here or doing Badge Life or any other conferences? Oh, I guess there's other conferences we could mention real quick as well.
Yeah, so a conference I'm really excited about is coming up this November. 2nd, 3rd, and 4th in Pasadena, California. This is the Ultimate Hardware Conference, whose title is the Hackaday Super Conference.
All these superlatives. I never was a fan of the superlatives, but
it is really an amazing conference. I was blown away. You were a big part of it and continue to be. You're going to be there this year, right?
I will be there.
I will be there as well. I'm totally looking forward to it. I was blown away by the hardware hacking every year, but especially last year. So we added like Friday afternoon. And it was going to open up at noon, and we had people like showing up at 10, and they're like, hey, is it like open up yet? And like by noon, all of the soldering stations were completely full, and then remained completely full through the entire weekend. And just had amazing hacks. Like these badges had color OLED screens on them, and then I think his name's Ben, put two of them together and made a VR. Like hooked
Ben
them
Henke,
together. And then it had parallax, so like the two images matched, and like I tried it, and like actually worked. There's just like crazy stuff going on too. People bring demos. So Elliot Phillips, who's a Hackaday editor emeritus, brought that thing that was like two buckets that you put on your head. And then they're connected by like a flexible
it's
HVAC
like a
conduit. And so it's like echoey, and you can hear back and forth between each other. And then like each person has a control that affects these flashing lights for the other person. And I don't know, it's just like a really interesting experience. And then, well, there's serious talks. I mean, it's really a conference about hardware creation. We have 2 talk tracks and we have workshops and that sort of thing. But it's really the people that are there. This we call it the Hacker Village, but it's this community of people, and like
it's an alley out back.
Yeah, I go through that alley at like each turn of the hour, and I'm like, okay, time to go back into the talks now. Like everyone's just having so much fun interacting with each other that they're like, oh yeah, there's. I wanted to see that person, that person talk.
I think that in real life IRL, that's an important thing. You know, it's hard to find these days. Finding like tribes of people. You know, Badge Life is like that here, and you know, Hackaday SuperCon is like that too. So, kindred spirits.
Yeah, and I think, you know, DEF CON has a ton of tribes of people, and I feel that the majority of them are happy to welcome new people to those tribes.
Yes, and I've learned that since. I guess I should follow up with that too, since I said it felt cliquey, but it was because I didn't know what I was looking at first, and then subsequent things, it felt much more, you know, and it's like, I think the tact you took was right. It's like, get to know people, take a chance.
Yeah, I had someone on Twitter this year be like, well, I'm not very outgoing, and it's like, grab a piece of hardware that you've built. Like, I'm just standing in the hallways with this Galaga badge, and people are walking by pointing at me yelling, Galaga badge, and that's your icebreaker right there. And, you know, you could try that anywhere, but it works better at hacker conferences.
It does. It's weird at the supermarket.
Yeah. Actually, so we play these outdoor concerts with the orchestras, and there was like a beer tent afterward, and we're standing at the beer tent, and I brought the badge because I've been telling people what I've been doing.
Exactly,
and, you know, I get this like really bright blue and red lights blinking. I'm the only one with it, and my wife's looking at me, and I'm like, people don't want to see blinky lights, do they? And she's like, no.
She's
so
like,
I just shut
cool
it
it, nerd.
But I'm not embarrassed.
Yeah, good. Well, thank you for talking to me, Mike. Where can people find you online, and how do you spell your name?
Oh, yes, I can spell my name for you. Well, first of all, go to hackaday.com and read the amazing editorial work that our entire staff is doing. And hackaday.io is our community site. Please, we would love to see your projects. Post up about it there. My great advice is post project logs as you go. It's
better than, don't say you'll do it at the end, right?
No, it's too big of a job. No one's ever going to do that. And, you know, crappy project logs are better than no project logs.
And it draws people to you for getting help and advice. And
yeah, you can form a
very positive
collaborative team there.
Yeah.
I'm also trying to build up to 1 million Twitter followers.
Oh, yeah? How are you doing on that?
Yeah, I'm not...
1/2000th of a play
there.
Yeah,
yeah, I'm very small. Yeah. So, so follow me on Twitter. It's really easy. It's at SZCZYS.
Yes. Yeah.
I had my most like influential tweet ever this week.
Oh yeah.
Because I tweeted out about that article that we got out right away on the original DEF CON badge.
Oh,
and then it got like 100,000 impressions or something.
Right. We didn't actually mention that, but I think there will be hopefully other coverage about that Toy Makers badge was great. So.
Oh yeah, that's incredible. You got to have them on.
Yeah. Well, we'll point people to your article in the meantime.
Oh, thank you very much.
All right, Mike. Thanks for joining me.
It was a pleasure. You know, I was on NPR.
What?
I was on Science Friday.
Really?
Yeah.
I didn't know that. Oh, for Hackaday Prize?
Yeah.
Huh.
I used my NPR voice.
Let's hear it.
Hi, this is Mike from Hackaday.
I'm Terry Gross.
No, but like,
welcome back to Fresh Air.
You go to like the local affiliate,
right?
And
you're not
it's like live, right?
Yeah.
And so they sit you way ahead of time, and you're sitting in this like dark, you know, quiet. They've got all the.
Can I get a cup of tea, please?
Yes.
Chamomile. Chamomile.
Sweaty balls.
Sweaty balls.
The official food of NPR.